I'm audible to you all.
Yes, sir.
Can the host kindly grant the sharing option? Okay. Yeah, thank you. So kindly wait for another 1 more minute till the other participants join in. So in the meantime, you are free to ask questions if you have any doubts from the previous classes.
Good evening, sir.
A very good evening.
Good evening, sir.
Good evening. Good evening.
Good morning.
Good evening. So in the meantime, till we begin, if you have any doubts from the previous classes, you can you are free, feel free and ask the questions.
No, sir. No doubt, sir.
So I just want all
No
of
doubt,
you
sir.
to go back and check your practically app and answer to practice set 6.
Yeah, wow.
Yes, sir, no doubt, sir.
Okay. So kindly wait for a few more seconds before we begin.
Okay, sir.
Good evening, sir.
Good evening, sir.
Good evening.
Good evening, sir.
A very good evening.
Sir.
Good evening.
Good evening, sir. Sir. Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening. So, Lakshman sir, are we ready to start?
Sir, could you
Yes, slowly.
explain slowly?
You can carry on, please.
Okay, thank you, sir. So I'll just introduce you into today's topic. First, we'll do some revision. So before that, I'm going to mute you all. I'm going to mute you all so you can put your comments on the chat box and we'll take up and question answer session towards the end. Okay. So if you have any issue with the audio, please feel free to put that on the chat box. So I'll be looking into the chat box. So currently, before we begin, let us first of all see the following, what we did in the last class. Anybody remembers what was the title of the last lecture? That is lecture 11. I had connected the number of the lecture 11. So 11 was a magic number. So last class was other magic numbers. So last class what we learned is how to do multiplication with some special kind of numbers like multiples of 9 or maybe 11 or some special cases like that. Today we will see even more special cases of multiplication. So are you ready to start? So if you are ready, kindly put yes in the chat box. Okay, yes. So we are ready to start. I can see the responses coming in. So today's lecture is titled Special Multiplication. So today and tomorrow's class, we are going to cover multiplication and cover a lot of topics to make multiplication so much simpler. So let us start today's class with a small puzzle. So this is called what is wrong with multiplication. So you can see some figures that are written here. And these figures are not seemingly correct, isn't it? So everyone knows 12 into 12 is not 9, but it is 144. But then there should be some relationship between 9 and 144. Can anyone say what is the relationship? It is a topic that we have already done. Can anyone say what is the relationship between 144 and 9? Yes, Anirudh has said that it is the digit sum. Yes, correct. So currently, let us call as the sum of digits. So sum of digits is just adding the digits. You won't compute the digit sum. So sum of digits of 144 is 9. What is the sum of digits of 23 squared? Anyone know what is 23 squared? If you know the multiplication table, do you know? Okay. So we have not learned the multiplication table beyond 20, isn't it? Yes, somebody has said 529. We'll come to that, how we'll find that out. So today's lecture is all about finding the square of these kind of numbers, like two-digit numbers, where you have the repeated multiplication of the same number. And some of you are answering it is 529. So what is the sum of digits of 529? So let me just check that. Sum of digits of 529. So this is nothing but 5 plus 2, which is 7, plus 9, which is 16. That is right. Hello. Am I audible now? Can somebody put in chat box? I can see thumbs up from Mahindra. Yeah, good. So sorry for that network issue. I'll just share the slide once again. So hope the slides are visible. Okay, thank you for that. So what we were looking at the last point was that we have to find what is the sum of digits of 34 square. So we'll do this in a bit. But before that, I want to explain something about this term called as flatland. If you are into the habit of reading, you might have come across this book known as Flatland. It is all about life in one dimension. Suppose you did not have this 3D world around you, you only could travel around one dimensional space or something like a flat plane. You will see everything in the world was flat. So this is some kind of idea that we are using in this kind of problem. 12 squared, we are not finding the actual answer, but you are finding some kind of sum of digits of that. So we'll explain more about this in a later lecture. So let us see a continuation of the multiplication that we did in the last class. So we wanted to multiply some number like 309 times 104. What did we learn in the last class? That if the numbers are close to the base, we can express how much close to the base it is. So for example, in this case, 309 can be written as 3 times 103. And that should be multiplied by 104. So these both numbers 103 and 104 are close to the base 100. So this is 3 more than the base 100 and this is 4 more than the base 100. So we know the rule. This has two parts to it. So the first part is just the product of these two, which is 12. And which is the other part? You have to cross add. You have to do cross addition. 103 plus 4, which is 107. So the final answer will be 3 times 10712, which is nothing but what? 321 and 36. So let us do a few more of these kind. Can anyone say how can we split 192 times 92 so that it comes to the base closer to 100? If you know the answer, please type that on chat. So the particular solution that I'm going to give is 2 times 96. So 2 times 96 times 92. That is what we have to find. Now 96 is 100 minus 4 and 92 is 100 minus 8. So this answer is going to be 2 times of 4 into 8 is 32. And you have to put that separator. And again, you can do cross addition. 96 minus 8, or you can do 92 minus 4, which comes to 88. So what is this? Double of 88 is what? 176. And double of 32 is 64. So you can see this multiplication, even though it is hard to do without doing these steps in the Vedic mathematics procedure, if you are doing the conventional manner, it would have taken more space to write these down. Now, because you have applied this closer to base technique, you can simplify and make these calculations even more faster. So let us do the second one. So what is the rule that has to be applied for the second one? There is 47 and 98. So instead of splitting 98 or 47, what we'll do is we'll double 47, because double of 47 is 94. And we'll multiply that with 98 and we'll divide the entire answer by 2. So this is the procedure that we are going to apply. Anyone, can you write what is 94 times 98 in chat? So this is minus 6, this is minus 2. So that will be 12. Now separator is there, minus 2 plus 94 is 92. So this answer has to be divided by 2. So the answer is going to be 4606. Yes, I can see many of you posting the answer. Thank you, Maunika, Mahendra, and Krish. So let us do this last one now. 192 times 44. Now here is a trick. You have to apply both these together. In the first case, we split 192 as 2 times 96. In the second case, we had doubled 47 and halved the answer. So in this case, what you can do is transfer the 2 from 192 to 44. So this will be 96 into 88. Is that right? So we can write 88 as 100 minus 12, 96 as 100 minus 4. So the answer is going to be 48 on one side, and it is going to be 88 minus 4, which is 84. Yes. So Anand, Maunika, Jyotish, you have got it right. So hope you have got this idea firmly embedded onto your mind. So this is a very useful technique whenever you have numbers close to the base. Now we are going to learn a few more, which will essentially help you find what is the square of 34. So we are going to connect via local buses. Oh, sorry, it's not local buses, it is local bases. So you can see in a city, you will see the places are connected via local buses. So sometimes you will be far away from the true base. So in that case, you will have to connect via local bases. I'll talk to you about what it exactly means. So let me take an example over here. So these are other variations of the multiplication that we are going to see. Now, the multiplication is between 213 and 203. So the base has changed. We have only learned how to do multiplication close to the base 10, base 100, or base 1000. But now is the question where you have base as 200. Now this is called as a local base. Still, we can work this out with some careful planning. Now the base 200 is 2 times the base of 100. So still you can write what is the excess amount that you have above 200. Here you have plus 3, here you have plus 13. So one side of the answer is still going to be 13 multiplied by 3, which is 39. What is the other part to the answer? We have to do cross addition, isn't it? So doing cross addition, what you get is 213 plus 3. What is 213 plus 3? Which is 216. But this is not quite the answer. To get the answer, you have to multiply how much is the multiplication factor above the base 100. And that factor is 2. So the answer is going to be 43239. I can see few of you have already written the answer. I hope you are using the calculator. If you are using the calculator, for the remaining part of this lecture, please keep that calculator away. So the method that we are explaining here is slightly different from the previous one because of the fact that the local base that we considered here is 200, and 200 is 2 times 100. So that is the reason why you have to multiply by this factor of 2 to get the correct answer. Now I'll ask you to solve the second one. What is the local base here between 29 and 28? The base is 30. So 28 is 2 away from 30. 29 is 1 away from 30. So we can do the usual multiplication to get minus 1 into minus 2 is 2. What is the other part? The other part is to do cross addition. So you'll get 27. But here you have to be careful. You have to multiply by the factor of that base, which is 3. So the answer is going to be what? 3 times 27 is 821. So this is going to be 812. Yes. So what was this factor? How did we find this factor 3? Because the base that we consider here is called as a local base, and this local base is going to be 30. Since it is 3 times the actual base 10, we have to multiply by this factor. Okay, very good. Let's go to this number that we had to find. What is 34 square? Again, we have the base as 30. So this is plus 4. This is plus 4. So what do we get here? 16 is one side, but 16 has to be written a little bit carefully with this carry. Now you do cross addition, you will get 38. you had to multiply by 3 because the local base here is 30. So the answer is going to be what? 90 plus 18, which is 108, 1096. Am I getting it wrong? Let's check. So square of 36, 34. What is the square of 30? It is 900. So we'll get 34 square as 30 plus 4 square. So this is just a verification. So you can use the commonly applied identity. What is this? 30 square plus 16 plus 2 times 30 plus 2 times 30 into 4, which is 240. So are we getting it right or wrong? Is this 105? Okay, so somebody has told it is 1156. So let us check what went wrong here. So 30 is the base here. So what we have multiplied is 4 and 4, which is 16, which is correct here. What is 3 times 38? 90 plus 24. Okay, so here 90 plus 24 would have been what? 114. So the mistake was here. So let me just cancel this answer. So we have still the 16 here, and 3 times 38 is 114. So this answer is 1156. So thank you for all the students who had written the answer. So what is the sum of digits of 1156? 1156 has the sum of digits as 7 plus 6, which is 13. So the answer to the first puzzle that we were asking is what? It is 13. Let us do this one where we have 4 digits appearing now. So this is plus 3 above 5000. This is 108 above 5000. The local base is 5000. Now you can do 3-digit multiplication here to get what? 324. And the other part is nothing but 5 times the cross addition, which is 1. What is cross addition? 5, 1, 1, 1. Now you have to do this multiplication a little bit carefully. What is this? 5, 5, 5, and 25. And then you have 324. Yes, Mahendra, it seems your answer is correct. Let us go to the last problem over here, which is to do 902 plus 909. So again, the local base is 900. So this is plus 9 above that local base. This is plus 2 above that local base. Now you can do the product. Product is 18. So 18 is 2 digits, which corresponds to the actual true base, which is 100. So there is no issue. Now this should be 9 times the cross addition, which is 911. So the answer is going to be 998118. Yes. So I can see Mahendra has answered. So hope others have also got the technique. So I will urge you to keep a pen or a pencil and paper ready for doing these small calculations. So whenever you're coming for the class, keep a pen and pencil ready by the side. So now we are ready to go to the next part. We are going to take a little bit more harder number and let us see if it is possible. So we are going to multiply this big number by this number 270. So do not use a calculator. We are going to do this. If not on the head, let us at least do it on hand or a small piece of paper. We are not going to use the conventional method. Now somebody has to tell me how we can do this splitting of the number more easy. So this is a large number, isn't it? What is this number? This is 6,54,363 multiplied by 270. So 270 is a smaller number, easier to deal with. So you can split this in two ways. So by observation, this is 300 minus 30. So what does this do? Now, the special fact here is that if you find how to multiply this large number by 3, you can get the answer, isn't it? That you need only to multiply once. But suppose you can apply some other rules. For example, multiplication by 9. You can write 270 as 9 times 30, isn't it? And do you know how to multiply a number by 9 easily? We have talked about in the last class. What was it? We have to write this particular number, but now starting with the first digit as it is. So I'm going to divide, I'm going to multiply the large number by 9. So first digit is kept as it is, which is 6. The next digit is 5 minus 6. This digit minus the first digit, which is 1 bar. The next is going to be 4 minus 5, which is again 1 bar. Next is 3 minus 4, which is again 1 bar. Next is 6 minus 3, which is 3. Next is 3 minus 6. What is 3 minus 6? It is 3 bar. And the last one, you have to put a small 0 over here. 0 minus 3 is 3 bar. So this is the result that you are going to get when you multiply 6,54,363 with 9. So again, you have to multiply this with 30. But you can split 30 as 3 into 10. So the answer is going to be 18, 3 bar, 3 bar, 3 bar, 9, 9 bar, 9 bar, and 0. So I have got my answer in terms of a bar number here. Now the only thing that is left is to convert this bar number into actual number. So we are done with this multiplication. So how to convert this bar number back? So look at these combined, 18. So 18 has to give a carry. Now you can do all from 9s, last from 10. So this is 17, and the next number is 6, 6, 7. Again, this 9 has to give this a carry. So this has to be 8. And this should be all from 9s and last from 10. So 0. And last from 10 is 1, 0. So is this the answer that everyone is putting in the chat box? 17667A010. So in fact, this was one of the problems that was given as a tagline to this course. So if you see, one of the messages that you got in the tagline of this Vedic Math course was this problem exactly. Can you do this problem on your head? So currently we are not equipped to do this on the head, but we could do in a small piece of paper, or maybe if you can jot something on your hand. Next time we'll learn some more tricks to do this on your head. So I can see many of you have posted the answer before me. It seems that many of you are using calculator. So kindly keep the calculators away from the Vedic Maths course. So let us move ahead. Now this time you will have a very interesting puzzle. This time calculators will not be of much use. So this is the puzzle. So you have been given with 9 boxes here. You have to fill each of the boxes with numbers starting from 1 to 9, such that all the relations here are given in terms of multiplications. So you have to satisfy all these 6 multiplications together by filling the numbers 1 to 9. This is a little bit interesting one. But along with this particular puzzle, we are going to learn an important technique called as factorization. So if you have heard about factorization, put Y on the chat box. If you have heard about factorization, put Y in the chat box. Yes. So I can see few of them are giving replies. So can I get more replies? Yeah, somebody said prime factorization. Yes, in fact, we are talking about prime factorization. Okay, so we are going to factorize each of these numbers over here. So what is 54 in the prime factorized form? So we know there is 54 is what? 9 times 6. 9 times 6. In 9 there is a 3 squared, and in 6 there is a 3 to the power 1. So this is 3 cubed into 2. What is the prime factorization of 120? So 120 is what? 2 into 60. 2 into 60, again we know 60 is 6 into 2 into 10. Sorry, 60 is 2 into 30, which is 2 into 3 into 10. So let us have this number first written as 2 times 60 initially, and this is 2 into 2 into 30, and this is nothing but what? 2 into 2 into 15, but 15 is nothing but 5 into 3. So we have got I should put a 2 square here, so 2 cube into 3 into 5. So this is the prime factorization. What about 56? 56 is nothing but 7 times 8. So this is 2 cube times 7. Everybody is clear on prime factorization? Okay. So let us do 21. 21 is nothing but 3 times 7. What is 180? It is 90 times 2. So 90 times 2. Let us do a primary exercise here. 2 times 90 is 2 times 45 into 2, which is nothing but 2 squared into 3 squared. 3 squared is 9. This is to be multiplied by 5. So this is nothing but 2 squared into 3 squared into 5. And the last one over here is 2 times 48. So how can you write that? 2 times 48 is nothing but 2 times 2 times 24. 24 is what? 8 times 3. So this is become 2 power 5 times 3. So here we have done a prime factorization. So I'll just make things a little bit more clear. So what is prime factorization is exactly we are going to write the numbers in terms of powers of prime numbers. Everyone know what is the power of a number? Suppose we want to raise a number, say 2, to the power of 2. We'll write this 2 as a superscript. It means that this is 2 into 2. So suppose it is 2 power 3, this is 2 into 2 into 2. So like this, we are expressing each number in terms only of prime numbers and its powers. So if you see, the first number over here is 54, which is 2 into 3 cube. Now here you see 3 into 7, but 7 is not a prime factor here. So 7 cannot be written here. What about here? 120 is 2 cube into 3 into 5. You have a 3 which is common, but you do not have a 7 here, which means 7 can appear only here. So we are trying this puzzle now using prime factorization. So we got one box correctly now. This number 7 can only appear here. Why? Because the prime factorization of 56 has a 7. Prime factorization of 21 has a 7. None of the other numbers have a 7 as a prime factor. Now, similarly, you'll observe a prime factor of 5 appears only here in the middle, the central box, because 180 has a prime factor of 5 as well as 120 has a prime factor of 5. Now, we can go on finding the other numbers. What do we do? So now, I'll just solve for one more and ask you to solve the remaining at home. So how do we solve the remaining? So now we have a 3 factor coming in here and a 3 factor also here, but you cannot write 3 here, isn't it? So you have to check for whether there is a common functionality coming. So you can see 2 squared into 3 squared into 5. So the remaining part here is 2 squared and 3 squared. But there is only a factor of 2 that is coming here, which means you can write a factor of 2 coming in this. And the remaining number, which is what? 3 squared. Can you put somewhere? No, you cannot put 3 squared here because there is no factor of 3 that is here. So this number has to be 1. And this number has to be 2 into 3 squared. So given all this hint, I will ask you to solve this as a homework. So what new technique have we learned here? It is prime factorization. So I'll just stop for a moment here to revise what we have done until this point. So till this point, we have learned about multiplication close to the base. And also we have learned multiplication with special numbers. Now, again, we can do a lot of simplifications. And this is what we are going to look in this slide. So let us see. So the example that we are going to do here is something like you have a number like 52 times 58. What is the specialty of this number? The first digit is the same and the last digits add up to 10. So this is a very special number. So what you have to do to solve for 52 times 58 is you have to multiply these numbers 2 and 8. So that is 16. There are two parts to the answer as we had in many of the previous examples. The first part to the answer is going to be one more than the one before. And we are going to add 1 to the number 5, which is 6. So we have to do 5 times 6. So the answer is going to be 3016. So let us see how many of you have got this right. Somebody is telling it is 3010, 3106. Is it 3106? Nobody seems to have got the answer. It is in fact 3016. You can check that out. Yes, Mahendra has confirmed, Krish has confirmed. So I hope by doing this practice, it will be more clear. So let us take this practice up. So what is the rule that you have to check? The first numbers have to be the same, which is 4 and 4. And the last numbers have to add up to 10. So yes, I can see many answers flowing. So what is the first part? It is 3 times 7, which is 21. And the initial part is 4 times 5, which is 20. So the answer is 2021. What about this? 62 multiplied by 68. So this is going to be 16. This is going to be 6 times 7, which is 42. 4216. Good. What about this larger number? 204 and 206. So here we have to consider this as a single number. And the last part is 4 and 6. So the last part will be 24. And you have to be a little bit careful. The base is now 100. So you'll have to be a little bit careful. The first part to the answer would be what? 20 times 21. 20 times 21 is nothing but 420. So the answer is going to be 42024. Yes, I can see Nilesh. Nilesh, what are you trying to say? You are saying A minus 2001. Some people have some confusions regarding this. So let me clarify this once again. So if you have not got the answer, I am explaining for them once again. So let us take this particular number, 43 times 47. So you can see the first part of these numbers are 4. And the second part is 3 and 7. So the only check that you have to do to apply this rule is that the first numbers have to be the same. The second part of the numbers has to be adding to 10. So the numbers adding to 10, you have to find the product and put it as 21 here, 3 times 7. And the remaining part is 1 more than 1 before. So you have to do 4 times 4 plus 1. 4 times 4 plus 1, which is 20. Okay, so now let us do a few more things here. We are going to see some useful products. So this is special multiplication. So one useful product to always keep in mind is this number 67 times 3. I will display everything together. You can learn them up if you can by heart, so that your multiplication will become even more faster. This is a magic number, 37, and everyone should know about 37 times 3. So we know that 11 is a magic number. Why it is? Why it is? Because we can do multiplication by 11 just by doing something called as addition. So if I want to do 72 times 11, I can write 7 2 separated by a gap, and in this gap I can just write 9. So this is the beauty of multiplication with 11. Similar is how 37 also behaves. So 37 times 3 is 111, which you can apply in a large number of multiplications. I'll show some examples shortly. So another example is 43 times 7, which is 301. You can also learn 29 times 7, which is a useful product, 203. And the last one is 23 times 13, which is 301 bar. What is 301 bar? 301 bar is 299, because 1 bar corresponds to -1. Okay. So I'll just show a few examples with these magic numbers. So let us practice these. So what is 74 times 27? 74 can be written as 37 into 2 and 27 as 3 into 9. Now you want 37 to be combined with 3. So 37 into 3 is 111, and 2 multiplied by 9 is 18. Now you can do this easily. How do you do this? So similar to your multiplication by 11, there is a rule here as well. So you write 18 as it is. You have 111 coming like this. So for the first number is going to be what? 8. Then you can write 18 and 111 like this. So this is sum, which is 9. Again, you have one more, 18, 111. Again, you will get 9. And the last one, I'll write it here, 18, 111, which is 1. So this answer is going to be 1998. So multiplication by 111 can be done very easily as it is done for multiplication by 11. Let us do another example, 43 times 49. We know 43 times 7 is what? 301. So this is written as 43 multiplied by 7 into 7. So this is 301 into 7. This is 21. And you have to be careful here, 07. It is 2107. Yes. So last example, 23 times 39. We know 23 times 13 is 301 bar. So 23 multiplied by 13 into 3. This is nothing but 301 bar multiplied by 3, which is 903 bar. This is what? If you know the answer for 903 bar, put that in the chat box. Yes, Anand, you're right. This is 897. So very good. So currently what we have learned is a lot of techniques for doing special multiplication. We'll do one last thing and we'll go to the puzzle. So this is first by the first and last by the last. So this is somewhere close to what we learned earlier. I'll explain this once again. So in the earlier slide, what we had learned is, suppose you have a number like 52 multiplied by 58, where first numbers are matching. You could do this one more than the one before. Here, the setup is almost similar, where you have the last numbers are matching each other and the first numbers are adding to 10. So here also you can apply a similar rule. You can do 7 times 7, which is 49. But now you have to do 2 into 8 plus 7. 2 into 8 plus 7. Why is 2 into 8? 2 is here, 8 is here. You have to add a 7 to it to get the correct answer. So this is 16 plus 7, which is 2349. Yes. Let us do one more example. 69 times 49. 9 into 9 is 81. And here you have to do, to get the first part, 6 into 4 plus 9. What is 6 into 4? That is 24. 24 plus 9 is what? 33. So this is 3381. Okay. So there are a few questions that have come. So I'll take them towards the end. So last one for you is 91 times 11. So what is 91 times 11? So this is a magic number again. I will explain once again how you can do magic number multiplication. So before that, we will apply this particular rule that we learned just before. So we'll do 1 times 1, which is 1, but probably we should put a 0, is it? Let us think about that. So this first part is going to be 9 times 1 plus 1. So first part is going to be 10. So in fact, you have to put a 0 because this corresponds to 2 digit. So this is 1001. So this is in fact another useful product to learn. Now let me explain to you what is the magic property of 11. So 11 multiplication can be done just by putting these numbers one space apart. So 9 and 1 can be written with the middle number missing. And the missing number is the sum of the digit. Sum of the digits, 9 plus 1, which is 10. But 10 will cause a carry to 9. So this answer has to be 1001. So this is for Mahendra. I don't know the initial. Mahendra was asking what is the magic property of 11. So we'll skip this part. I'll take in the next lecture. So we'll directly go to the part of the puzzle. So here is a puzzle for you to solve for today. So I'll give you the initial hints and you can try these at home. This is similar to the prime factorization that we just did in today's class. So are you ready to hear this problem? Yes. So let us see what is the problem about. The problem is about the product of two whole numbers. So what is the whole number? How is it different from natural numbers? So whole number is nothing but the set of natural numbers plus the element 0. So you are allowed to do product with zeros also. So you have two numbers, say x and y, and the product of these is 10,000. Now both x and y is not a multiple of 10. These do not have a multiple of 10 individually. Now you have to find what is x plus y. So now, essentially, it is saying that you have to prime factorize 10,000 and find out how you can split those factors so that x and y are not multiples of 10. So I'll just give you this answer. So this is 10 power 4. 10 power 4 is 100 square. 100 is nothing but 4 times 25. So it is 2 squared is 4, 5 squared is 25. So 100 square is 2 squared into 5 squared, the whole square. So this is 2 power 4 into 5 power 4. So now you can see how you can split these factors to get x plus y so that both x and y are not multiples of 10. So I'll just stop here and take up questions from whoever has doubt. And you can solve this current puzzle at your home. It will appear in the Practically app. So the procedure for asking doubts is that you have to raise your hands, because if I unmute you all, there will be a lot of noise. So you can raise your hands if you have doubts, or you can also put your doubts in the chat box. Yeah, please do not answer this in the chat box because it is going to appear as a quiz. Yes, I can see Nilesh has raised his hand. You can unmute yourself and ask your question, Nilesh.
Sir,
Yeah.
sir, you have given this question for doing homework.
Yeah, this is a homework question.
Okay, sir.
So I can see Tarun Kumar. You can unmute and ask, Tarun. Yeah, Tarun, please go ahead.
Hello?
Yeah, please ask your question.
Sir, what is the magic number? Sir, what is the
Okay.
magic number?
Okay, magic number. So currently we have learned a lot of magic numbers. So magic numbers are nothing but numbers which you can multiply very easily. So one magic number that we have learned is 11. I have shown how to multiply by 11, right? So you take 11 multiplied by some number like 39. How do you do this? Write 3 and 9 separate and you add the sum of 3 and 9, which is 12. But you have to take care of this carry. This answer is 429. So this is why it is called as a magic number. You can do multiplications easier with the magic numbers. So I'll go to the next question. Anand and Harsha, you can unmute yourself and ask.
Sir?
Yeah.
Sir, can I tell the answer?
Please don't speak out the answer for this puzzle now. It will be appearing in the Practically app so that others also can solve it.
Sir, at which page, sir? Practical, in which it will
So
appear,
today, yeah, you go to Practically app. There will be some notification that will be appearing today.
Okay, sir.
You look for the notification. Okay.
Okay, sir.
I'll go to next Hasini Priya. You can unmute yourself. Hasini Priya Gautam. Yeah.
Sir,
Yeah. Please ask.
sir, you said we can see this class in YouTube, na sir.
Yeah, it is available in YouTube also.
What we should search in search button, sir?
So you search for practically live Vedic Maths. So you will get this particular lecture available in YouTube as well.
Sir, we can see only Vedic Max class.
Yeah, currently I think it is only Vedic Maths, but you can check for other subjects as well. I'm not aware of the other subjects.
Okay, sir.
Okay, thank you. So let's next go on to Yatin and Yashwant. Yatin and Yashwant, you can unmute. Yeah. Sorry, your audio is not clear. Yatin and Yeshwant, can you try once again?
Sir, once again, sir.
I can't hear you. So I think we have exceeded the time. So those participants who wish to log off can kindly do so. The class is over for today. So those who have doubts kindly remain. So I'll answer all your doubts before ending today's session. So Yatin and Yeshwant, I cannot hear what you're saying. Kindly type your question in the chat box. Next is Mahendra Romichella. Mahendra, you
Hello,
can
sir.
unmute your.
Yes, sir.
Yeah,
Sir, can you
please.
explain what did you explain in before lecture, sir? Means like what topic did you say about, sir, in our before lecture? Means like I didn't
So
attend on that day.
only last lecture or only last lecture? Mahendra, you unmute once again. Yeah. So are you
Yes,
talking
sir.
about last lecture?
Yes, sir. Our last lecture, 11th lecture.
Okay. So in the last lecture, what we saw was some special kind of multiplication with numbers like 9 or numbers like 999, etc. How we can make these multiplications simpler. So I'll give you an example on multiplication by 9. So any number, if you want to multiply by 9, you can do it very easily. Suppose I want to multiply 79 times 9. The usual method, what will you do? 9 times 9 is 81. There is 8 carry. Then 9 times 77 is what? 63. 63 plus 8 is 711. So this is what you are going to do. But in this method, you can do it even more faster. How is it? You write the first number as it is, which is 7. The second number will be 9 minus 7. 9 minus 7 is what? 2. And then you do 0 minus 9. 0 minus 9 is written as 9 bar because it's a negative number, isn't it? So this is 727 to 9 bar. This is equivalent to writing 720 minus 9, or this is 711. So you get the answer very quickly. So Mahendra, I'll just allow you to unmute once again and hope you have understood what.
Yes, sir. Understood, sir.
Okay, so
Got
this
it, sir.
was what we covered in the last class. Now let me go to Tarun Kumar once again. Before Tarun, I'll take up Ashraf because Tarun has already asked once, I guess. Ashraf, can you unmute?
Sir, I not understand prime
Factorization. Okay.
factorization.
So, okay, right. So prime factorization is a new topic that we have introduced only today. So don't worry if you have not understood it clearly. But I'll explain for your benefit. Let us take a number 54. So Ashraf, can you say what are the factors of 54? You can unmute yourself and answer. What are the factors of 54? Give me what is 54. Can you write it as a product of two numbers? 54 is what?
What?
Okay. Can I write it as 60 minus 6?
60 minus 6. Yes, sir.
Yes, 60 minus 6. Okay. So 60 minus 6, I can write 6 into 10 minus 9, 10 minus 1. Is this correct?
6 into 10 minus 1. No, sir.
Is it correct or not? It is also correct, right? Because 6 into 10 is 60, 6 into 1 is 1, and that is 60 minus 6. So this is same as 60 into 6 times 9. Correct?
Yes,
So
sir.
6 I can write it as 2 into 3, and 9 is 3 into 3.
3 into 3.
Now this is the prime factorization of 54. Another way of writing this simply is 2 times 3 cube, because 3 is repeating 3 times, that you will write it as superscript 3. Okay, I think Ashraf, your question will be answered in the future lectures. So I'll go to Tarun. Tarun, you can unmute yourself.
Sir, I can say the answer.
Yeah, Tarun, what is your question? I'll mute you because you are not asking any question. Guru Charan.
So good
So I
evening,
can
sir.
see. Yeah, please ask.
Sir, which classes you are telling this class, sir?
So this Vedic Math is not meant for any class as of now. Currently, we are having students from 6, 7 up to 10. Some students are also coming from 10th class. So this is a generic class right now. But these topics are very much like we are taking from the beginning. So you will not feel any kind of lagging behind. So
Okay.
which class are you in?
10th, sir.
10th, okay, 10th class. So are you finding these topics useful in your subject?
Yes, sir. Basics, right?
Okay.
Thank you, sir.
Okay, thank you. So I can see Krish has asked, he is having some doubt, but okay. Can you raise your hands, Krish, so that I can unmute you? I can. Okay. Let me just figure out a way to unmute Krish. Okay, I'm asking you to unmute. Probably now you can.
Yes, sir.
Yeah.
Sir, I have a question. Can you multiply like a 4-digit number with a 4-digit number using the simple method?
Yeah. Give me 2 4-digit numbers.
The 2564 multiplied by 8924.
Okay, so you want to multiply by this simple method. So this
Yes.
comes under, okay, this is under general multiplication. I'll talk about this in tomorrow's class. So there is no special rules you can apply for these. So for this, you have to use something called as general multiplication, which is also very convenient. You can improve on the speed of doing this multiplication also. I'll talk about that tomorrow. Okay, so I have got a question in the chat box. Sir, you have given which homework? I know the answer. Can I tell you? So Nilesh, kindly hold on with your answer. You can write the answer on the Practically app. Okay. So once again, I go back to Tarun. Tarun has raised his hands. Tarun, do you have a question again?
Yes, sir.
Yeah, please ask your question.
Yes, sir.
Ask your question.
Sir, I know answer. I can tell, sir.
Please don't answer here. You can write your answer in the chat box. Sorry, in the Practically app. Yeah. So I think we have more than exceeded the time. So I'll take one last question. Ritik has asked. Ritik, can you unmute yourself? Ritik. Okay, many students are trying to say the answer. For them, I'm just asking you to hold for 1 more hour. You will see the same question appearing in the Practically app. So there you can give the answer. So I think there are no more questions. So Ritik was unable to unmute. So I'm giving you one more chance. Ritik, if you have a question, please ask. Okay, I think he's unable to unmute. So with that, I will conclude today's lecture. Thank you for all the students who have stayed back this 15 minutes after the lecture for asking questions. I would like to hear from you how the feedback for this class is, whether you find it easy or a little bit difficult to follow. I'll be able to help you if you give some feedback. So with that, I will end today's class. Thank you and namaste. Yeah, thank you once again.